Hello all, let's start with our today's DSA with this amazing visualizer by ChaiCode at dsa.chaicode.com. Use this link to get a 700 free trial order discount. Okay, let's start with our today's topics, and now we complete our hash array and hashing completely. Now is the time for sliding window. So this is the overview of a sliding window. In sliding window, what I did actually, we take a window and we move the window. Maybe we reduce the window, maybe we increase the window, or maybe we just make the window same. And what is the window? Actually, a window is. So let's take an example. So first, let's this is an array. Okay, so a window is a part of this array. Okay, a part of this array. So this will become a window. This will become a window. So we can slide the window. Simply we just slide the window. We slide the window. We slide the window. We just make a slide towards end, or maybe from end to start, or maybe in some cases we just increase our window or we decrease our window. It depends on the question, because we slide the window, that why it is called sliding window. But now the question is, how could we actually get the window? Using pointer. Take two pointer, one L, one R. Left is here, right is here. In between all of this, into the sliding window. So simply here also, you can clearly see the key economy. When the window moves one step, almost everything inside it stays the same. Instead of recomputing from the scratch, we adjust one value, enters one value, leaves. Okay. So this is the window. The sum is 7. Okay. So let's do it here. So this is our window. What is the sum inside the window? 2 plus 4 plus 1. It is 7. Okay, so when we slide the window by one step, how could we increase our sum? How do we actually calculate our sum? Rather increase. 4 plus 5, 1 plus 5. But every time we have to compute. Rather than in the first step, we are having this like 2 plus 4 plus 1, that is 7 our sum. We slide the window. Now the windows is on 415. Okay, so which part is not here? This 2. And which part is new inside here? This 5. So add 5, remove 2. So this will become 10. Sum it. 4 plus 5 plus 1, 10. Similarly, we just take 10 and we slide the window. Okay, let's do a question to understand it much better way. And the question is maximum sum subarray of size k. Okay, so given an integer array and window size k, find the maximum sum among all contiguous subarray of length k. Okay, so the question is, we are given simple. Let's take it. This is our array. Suppose the value of k at the starting is 3. So k is 3. Our window size is also 3. Very good. So take the sum 2 plus 4 plus 1. Okay. The what is the sum? 7. 7. Our sum is 7. Now in okay. Now just increase the window. 4 plus 1 plus 5, 10. 7 or 10, which is better? 10. Just remove 7 and store that 10. Okay. Now increase the sum. 5 plus 3 plus 1, and it is 9. So 9 is greater than 10? No. Increase it. 5 plus 3 plus 6, 14. 14 is greater? Yes, 14 is greater. So it is 14. Okay. So now increase it. 6 plus 3 plus 2, it is 11. Is 11 greater than 14? No. So our answer is 14. We have to calculate the sum of the subarray of the size. Sum of the subarray of the size k, which is maximum. It's stored here. Find the maximum sum of any contiguous subarray with k, with size k equal to 3. Okay. So how could we do that? Okay. First, can we just recompute each window every time? Every time, just like this. We take a pointer, calculate the sum, take a j here, we increase it, increase it, we increase it, we calculate the sum, we increase our L and R, calculate the sum, calculate the sum, calculate the sum. Okay, but 215132. So what if at the starting we take an answer, let's take the answer ANS as minus infinity. Why we take minus infinity? Let's check it. At the end we just checking this. So first take one loop I from the starting, I from the starting, then take another loop which is j, also from the from where the I begins. Okay, and till we reach k element, each time we just increase the sum. Okay, so take a variable, another variable sum. So what is the value of j? J here, not I. J, 2, 2. Okay, and sum initialize with 0. We just add 2 into the sum. Okay, now increase the j. Okay, increase the j, that is at 1. So add 1, increase the j, that is at 5. Add 5. So now calculate the sum. 2 plus 1 plus 5, that is 8. The sum is 8. So now which is greater, sum or this answer? Answer is minus infinity, sum is 8. Obviously 8 is greater. So remove it and put 8 here. Okay, now increase the I, put the j at the point of I, initialize the sum with 0, initialize the sum with 0. Now add every element, like 1 goes here, plus 5 goes here, then plus 1 again goes here, so 3. Okay, so every time we have to put this, and how many times we just going to this? From I to j, this will be k. Okay, so j minus I is equal to k size. Okay, or k size, and but we just simply write our j loop from, it will starting from I position to I minus k minus 1 position. This is our j loop goes. Okay, from I till I minus k minus 1. Okay, and every time it will increase the sum into the sum variable. Same here. Sorry, this would be I plus k, I plus k minus 1. So the j minus I k, so j minus I will become k, the size. So j will become, or k minus 1, the index. So j will become, the last index is I plus k minus 1, the last index of j. Similarly here, just write down the pseudocode, that is function arr and k, take a max answer. At the starting it is minus infinity. Why minus infinity at the starting? Because anytime we get any value, we can easily add them up and get bigger value than minus infinity. So every time we are try to figure out the maximum value or the maximum sum value, so we can easily do it by this minus infinity. Okay, now just take a for loop. We are using two loop here. One loop is I from start to n minus k. Why n minus k? Because it will go till the point, this is the point that I is here L, so I goes till this 3 point, because the value of k is 3 and we have to traverse 3 element, because if the I goes here, then we cannot get 3 element at the left, okay, at the right, so we cannot do this. A sum initialize with 0, again a for loop j starting from I to I plus k minus 1, and sum every element into it. Okay, and calculate the max answer or max sum, that is max of uh, sum and max answer, and at the end return the max answer. Okay, using instead of, this should be array of j. Okay, let's wait for a few seconds, and this is the lead code question. Yes, we nailed it. Okay, so this maximum survey sum, the question here is, you are given an integer array nums element and add k integer, find the contiguous survey of length k equal to has the maximum average value. Okay, we have to return the maximum average value. So let's search this question. I'll back with this question also. Okay, so this is the question. The given an array of integer and a number k, return the maximum sum of survey size k. Okay, so first let's do the brute force solution. Int n equal to arr dot size. Take answer in minus infinity, and minus infinity is int min for integer. Let's take a max sum, it will be easier. Take two loops, one from starting to n minus k. Okay, and another one. First take a sum here. The loop, that is j from I to j less than equal to I plus k minus 1. Okay, then I plus plus, rather j plus plus. So sum plus equal to array of j. Now update the max sum. Max sum is equal to max of max sum and answer or sum return max sum. Okay. Yes, it's working. Let's run it. I think for the last case, it's give TLE. The last case, everything was passed. The last two cases. Good. Let's come with the optimized approach, which is a sliding window approach. Okay. Two consecutive windows share k minus 1 element. Going from I to k plus 1 to I plus 1 to I plus k. One element leave array of I, one enters array of I plus k. Update the sum in 0 of 1 instead of recomputing. Okay, so this approach tells a different story. So this is our array. Our k is 3. Our k is 3. So first go and take the sum of the first k element. Sum of first k element. Okay. We calculate sum of first k element, and the sum of first k element is 8. 8. 8. Now increase it. Increase the window size, or slide the window. A more proper word would be slide the window. Okay. When we slide the window, we just have to add 1, remove 2. Okay. Add 1, remove 2. It will become 7. Although it is not a maximum value, but it is working. Okay. So our first step is, and then again slide it once. From 7, add 3 and remove 1. Add this 3 and remove this 1. So it will become 9. Okay. Then again slide the window. From 9, remove 5, add 2. It will become 6. Okay. So our answer would become 9. Our answer become 9. But how? First take this and calculate the sum. Okay. Calculate the sum. So this will become, first take the first 3 element, these 3. Calculate the sum. The sum is 8. Okay. Put a pointer here. R. Any pointer you can. R. Our value of k is 3. R at k index. Why k index? It is 0, it is 1, it is 2, it is 3. It is 3. So R at index k. Okay. So add into the sum which we calculate here, that is 8. Add. Let's suppose A is our array, A of R. We are adding this one and remove A of R minus K. So the K value is 3 at the R at the index of 3. So A of 3 minus 3, which is A of 0, this index. So we add this index and we remove this index. We are removing this index, we are adding this index using this simple formula. First we have to calculate the sum here, then take a pointer to the kth point and just moving it one step ahead. Actually what it does, it first create a window like this, then take the window and slide it to here, then the r increase to here. It's slide, okay, it's it slide the window to here, it slide the window to here, then again the r increase, it it slides the window, okay, it slides the window to here, it slides the window to here. So it's actually with just one variable what we achieve it, we just implement sliding window. Simply in this visualization, take 215, the this is our window size. So sum of array of k minus 1. Okay, so this is our initial window size, this is our initial based window size. Then we increase our window, increase the r. So the out is our leaving element, our entering element is 1, leaving element is 2, entering element is 1. We just remove sum minus 2 plus 1, we just got 7. Then we again increase it, we remove 1, we add 3, we got 9, which is our best. We go here, we remove 5, we add 2, we got 6 here. So this is our best. So let's write the pseudocode, which is function it take array and a k. First max sum, let's take it like this, minus infinity. So now first take the sum of element of from I to k minus 1 into a variable sum. So we can clearly say sum become sum of array of from starting to k minus 1. Okay, now take a for loop for starting I from k to n minus 1. So the sum will become array of r minus array of r minus k. Okay, now simply update the maximum sum, max sum, max of max sum, and then sum, then return max sum, evaluate. Let's see it. Okay, we nailed it. Now let's go here and write the actual code. So this is our pseudocode. First take the size, which is nums arr dot size. Now take a maxsum int maxsum, which is minus infinity, which is int mean, int underscore mean. And first we have to calculate the sum of from 0 to k minus 1. So sum of 0 to k minus 1. Okay, okay, take a sum variable int sum equal to 0. Take a for loop starting from start I equal to 0 to I less than k, I plus plus. It take first k minus 1 element and add the sum plus equal to arr of I. Okay, using this we just calculate all the sum and put it into the sum, and now update the maxsum, or just put maxsum equal to sum, easily you can put. Okay, now take another loop. Now from k to n, so for rest of the array, so for int r starting from k, r less than n, r plus plus. So every element after k minus 1, just add the formula sum plus equal to arr of r minus arr of r minus k. We add some portion, then we remove it. Okay, now update the sum. So max sum will become max of max sum and sum. Okay, so for directly putting also it will work, no issues. We'll simply return max sum. Let's run it. Last time only 2 test cases doesn't pass. Everything passed. Okay, now it works. Let's copy the code. It works. Okay, so what this question tells, you are given an integer array nums consisting of n element and an integer k. Find a contiguous subarray whose length equal to k that has the maximum average value. Return the value. Okay, so what is the average value? If okay, let's take this array. Okay, and the window size is same 3. We just window size is 3. Okay, so k is 3. So what is the value or the sum of this segment? This window is 8. Just divide it by 3, we get our average value. This is our average value. We have to return it in double. Okay, so every time, let's say that, okay, everything, the sum is should, so the average value, every time we divide the sum by a single element, that is the k. Okay, we divided every sum by k because k is the size, so we divided every sum by this k. So sum, so we have sum and k. Okay, this is our answer. We have to return it in a double. Let's take it later. So this k is constant, so the k is constant. Now we have to maximize this value, this sum by k value. We have to maximize this sum by k value. How could we maximize the sum by k value when the k is a constant? By getting the sum bigger. So if we get bigger sum, more sum, then we easily can increase, we have the average automatically increase. If we have a bigger sum, the average will automatically increase. So in this question, our task is to find the maximum sum, similar to this question, and at the end just divide it by k. Okay, so I just, okay, just take the code from here. paste it, and everything here is nums. So this is a nums, okay, and everything here is nums, so the answer should be in double. So at the end, return maxsum by k. Just run it. Matching function. Okay, so double doesn't have the max function. Okay, so it doesn't take. Uh, we have to convert it into a double. So why I am doing this? Let's make everything double. I think this should reduce. Yes, it works. Just make everything double. The same code. We just make everything double. The two answer, the sum and the maximum, we just make it into double, and at the end we just calculate exactly in the same way, just the data type is changed, and at the end we just return maximum by k. Same answer, same. Just solve two question using the same approach, just to change the data types, and returning one in one case just divided by the k or the size of the window. That's it. So the time complexity is big of n, because we are just traversing here. We traverse from 0 to k minus 1, and in this loop we traverse from k to n, so at the end it's big O of n, and we are using a constant space, just two variables, so it will be a constant space time complexity. So space complexity, so time complexity would become big O of n, and space complexity would become big O of 1. Okay, also state here. And now we complete this question, max sum subarray of size k. Thank you for watching this. Go use this link to get a 7-day free trial. Use this visualizer by dsa.chaicode.com. Thank you.